Okay, so I decided to add a couple of podcasts to this course after a long time. Obviously, I'll keep upgrading the courses in some ways as I feel that additional new information or important information has come along. One of the things we looked at in Geoengineering Planet Remade was the impact of solar radiation management on hydrology and temperatures. It's fairly obvious that even if you do solar radiation management either through stratospheric aerosol injection or mirrors or whatever, any local experiment is going to have impacts globally and outside. And we looked at volcanoes and said typically volcanic eruptions were associated with droughts in the following years, which could be attributed to the stratospheric cooling by the volcanic aerosols and so on. So let's add a little bit more here in terms of model experiments that looked at impact of solar radiation management or solar geoengineering on climate impacts, hazards, and even economies, just as an addition to the things we have looked at. So let me start with this paper, which did a survey on how the solar radiation management is perceived in the global north versus the global south. And the idea is that the debate has and the research has largely been dominated by the Western world. So what does the Eastern world think? This includes Australia and Japan as well, which are part of the global north, as opposed to Philippines, India, China, and many other countries, which are the global south. So the questions were related to attitudes towards global warming, background information on stratospheric aerosol injection, and attitudes towards this injection, attitude towards generally science and the environment, trust in institutions, and respondents' discipline in study, and then multiple sub-questions. I just want to touch on this to show that actually in these surveys, it turns out that no matter whether you're looking at feeling about solar radiation management or solar radiation management as an option, or whether field tests would be okay according to the participants and their opinion on who should lead the research. And the main point here is that India and China generally have a very positive or fairly positive opinion about solar radiation management, and they would support the solar radiation management as an option in much larger numbers compared to Australia, Japan, Korea, which are the global north in terms of how rich they are per capita income, quality of life, etc. Supporting field experiments, again, some rich countries would support it, but India and China are again larger in number, and of course everybody believes that big emitters should lead the research. Okay, with that background, we want to worry about how solar radiation management at large scale to alter the evolution of future temperatures, global mean, global warming controls, etc. would affect temperature, of course, which is the main control we would look for, and what impact it would have on other hazards like heat waves, etc., and how that would affect precipitation. Because if we were to take volcanic emissions as a guide, then obviously you could have droughts, and in regions where the solar radiation management was not being done over. Okay, so this is from the GFDL high resolution model with low ocean resolution, which is aimed towards a forecast, and they consider solar geoengineering impacts on the absolute magnitude of double CO2 anomalies, and they are looking at impacts on surface air temperature, maximum annual temperature, precipitation minus evaporation, and maximum 5-day precipitation. And the impacts are shown as moderated and significant, moderated but insignificant, exacerbated but insignificant, and exacerbated and significant. To cut to the chase, the main message in this paper is that with these solar engineering, geoengineering experiments, they argue that in most places either the hazards as defined here are moderated and significant, so that's downward means, so look at this here, statistically significant results are indicated with bold colors, whereas insignificant results are shown with pale colors. You will see this here. The results for GeoMIP, which is the Geoengineering Model Intercomparison Project, are shown for precipitation minus evaporation and px, with columns colored to indicate the fraction of GeoMIP. All GeoMIP models show statistically significant reductions in temperature and maximum annual temperature. So combination of model results, but nonetheless the argument is that the extremes and hazards are largely reduced across the globe, and there are some examples of exacerbated and significant impacts here on temperature and here on precipitation minus evaporation, and so on. But if you look at most of the global south countries, or Africa, China, India, Philippines, and so on, the argument is that hazards are reduced by solar geoengineering. You have to keep in mind all the model uncertainties and so on and so forth. The other paper from the UK group is more sobering in terms of its conclusions. It looks at what are called large ensembles, where many large number of realizations with models are done, and the optical depth modification is used as solar radiation management scenarios. And here is a baseline scenario of no solar radiation management, and you are looking at surface air temperatures. So if you do no solar radiation management with the given climate scenarios, you are going to end up with global mean temperatures increasing as we expect, but various scenarios of solar radiation management would keep us down here. But that would obviously have an impact on precipitation, which in this model is uniformly, or in these large ensemble simulations, are largely increasing with various amounts for these scenarios of radiation management for 80 years of simulations being looked at. But the model does better in, the report, the paper does better analysis in terms of providing the sensitivity to CO2 equivalent, so converting methane, nitrous oxide, HFCs, etc. to CO2 equivalent, looking at temperature changes associated with solar radiation management scenarios shown before, and see that the range of precipitation changes in terms of sensitivity to CO2 equivalent and temperature change is not easy to predict at a regional scale. Okay, so the impacts are mixed. There are places where warming is happening and precipitation is increasing, and there are places where warming is not happening, so the delta T is negative when CO2 increases, but they come with precipitations being negative, change in precipitation being that it will be reduced. So obviously it's a complicated picture in terms of sensitivity. So if you want to look at economic impacts, this becomes critical as well. And they also look at the differences in level of solar radiation management, more versus less, so that approximate global mean surface air temperature is either not decreasing much or decreasing much more. And they look at example of 2020 India in the 2020s and 2070s comparing against 1990s. For India, the precipitation here and the temperature here, temperature here and precipitation here. So India has can experience cool temperatures as well as additional precipitation in the 2070s and both in 2070s and 2020s, whereas China on the other hand mostly experiences decreased precipitation for both the 2020s and 2070s. There are lots of details, as we've talked about in the monsoon case, the land-ocean contrast and how it responds to global warming depends on aerosols and other details which the models often are not representing properly, so one has to be careful. But nonetheless, point of this paper is more sober, and it says coming to agreements on consensus of how much and how the solar radiation management should be done is not going to be easy, because the regional impacts could be negative. Even though you cool the temperatures, you might end up reducing the precipitation significantly, which many countries wouldn't want, right? Keeping that in mind, we move to an econometric model which argues that inequalities or inequities among countries, global south and global north, can be reduced by solar radiation management. So it looks at various scenarios. It calls the regular RCP 8.5, which is a representative concentration pathway used in AR5. There were also shared socioeconomic pathways which combined just emission-based scenarios versus governance policies, choices in sustainability, and so on. And it looks at geo-stabilized RCP 8.5 scenario and geo-mirrored, which means each additional degree of warming is you can see that here is neutralized by radiation management, as opposed to geo-mirrored is the one where the warming is continuously neutralized by the radiation management, whereas geo-stabilized is where you keep the temperatures at the 2010 level. Okay, so this is the mean temperature and this is the mean precipitation change, and the argument in this paper is that the temperature and precipitation relation is such that, especially in the future, the temperature effects due to solar radiation management do not significantly affect precipitation, hence that's not a concern. And then they go on to use an econometric model which takes these precipitation and temperature changes and the historical relation between those and GDPs to say how solar radiation management will affect GDPs in the future. Okay, so here it is looking at GDP per capita in US dollars thousands of dollars, and looking at these different scenarios into the future. It is saying RCP 8.5 is here, and geo-stabilized scenario is here, where you fix the temperature to some 2010 level, and geo-mirrored experiment would increase GDP into the future and no change would leave it there. So RCP 8.5 dips the GDPs over time, geo-stabilized and is down here, and geo-mirrored is up here. So obviously the argument is that GDPs would increase if we used solar radiation management to neutralize global warming, and the distribution would look like this. So the RCP 8.5 has largely negative impact on all the global south countries, and even in countries like the US, very few countries benefit. Russia and Mongolia and some Asian countries here, and the Canadian region, okay, and many European regions. But when you look at geo-mirrored with RCP 8.5 and geo-stabilized with RCP 8.5, the argument is that most countries would have positive impact in GDP per capita, and there would be negative impacts on of course this is mirrored, so Canada and Russia would lose in this scenario, and the loss of US would be greatly reduced, but these global south countries would greatly benefit. Okay, and that would also change the distribution in terms of cumulative share of global GDP and cumulative share of global population. So RCP 8.5 would keep the large part of the population from having a larger fraction of cumulative GDP, whereas if you go to geo-stabilized, geo-mirrored, then you would actually increase the fraction of population which would share larger fraction of the global GDP. There are lots of uncertainties with these econometric models, and of course there are uncertainties with the projected scenarios used, and there are uncertainties in the relation between precipitation and temperature. So this is showing historical correlations between temperature and surface temperature and annual precipitation, how that changes under RCP 8.5 in terms of delta P over delta T, and how geoengineering affects delta P over delta T. So considering that it's the precipitation simulation and prediction are the most difficult for models, we have to keep these things in mind. But this set of results from different papers seems to argue that the temperature precipitation relation is critical, which may make it difficult to find consensus on how much and how one would do solar radiation management. But countries like India and China are much more optimistic about it than the rich countries, and in the East at least, Japan, Korea, Australia versus India, China, for example, and how econometric models and climate models argue that hazards would be reduced and inequities in terms of GDP and share of the global GDP would improve with solar radiation management. So with that, you have to make up your mind about how you would view geoengineering at large scales. Okay?